So now let's go into the practicalities of this course. So the course is going to cover multilinear regression. This is actually today's topic. And this lecture is more going to be about the general workflow than the nuts and bolts of multilinear regression itself. Then next topic is going to be classification, followed by clustering and principal component analysis. And after this, we are ready to come back to regression to talk about advanced regression methods. And last but not least, we put all of this together and we look into, on the example of non-targeted mass spectrometric analysis, how multivariate analysis can really make a difference. And actually, in all of these topics, we also have labs, not only lectures, and we are taking real data from different either public databases or publications, and we see how the multivariate analysis is making a change in analytical chemistry in really different fields. So we have examples about predicting disease, predicting retention times, but also choosing matrices for optimizing a method and validating a method. Then what are you supposed to or expected to learn during this last part of the course? So generally, we aim to create some understanding about the principles, advantages, and traps of multivariate analysis for each of the methods. You should also become able to apply regression, classification, and clustering, as well as dimensionality reduction. And this is something that we are mostly doing in the labs, but also with practicing that yourself after the labs and completing your lab reports. Then you also become able to analyze the results that you have obtained and also evaluate through this the suitability and efficiency of different methods. So do they actually perform as they should? Do they allow us to answer the questions that we are posing to them? And last but not least, we also are creating, hopefully, some gut feeling about which tools to use. So is this rather a regression task or a classification task? Is it maybe even a clustering task? And if it is a classification task, then which method to start with? Do I start with a KNN, or do I start with a start with a decision tree, or should I just try both out? So this is what we hope to develop during the course. So when we have the lectures, then I'm talking a bit on the background, but then we take also their breaks and we do exercises. And we try to, with these exercises, test how the math behind some algorithms actually works. So we do different exercises. Sometimes we use a bit of an Excel or a Google Drive document so that we can all see and all play around. Sometimes we use an R. Sometimes we do just something quickly on a paper, just to understand a bit more what is going on. And we also discuss in groups. So you will pair up or work in groups of 3 during these exercises. Then after each lecture, with the exception of classification, where we have 2 lectures and then followed by lab, usually the lecture is followed by 1 lab. And in the lab, we have 1 big task, and we are going through this together. I am providing to you a scaffold in our markdown document. And we are going to do some basic steps together there, but you are having also some tasks as part of this lab that will be part of your lab report. So wrapping it all together and answering the questions and completing some tasks, that is what you're going to do in the lab to submit the lab report. Importantly, the R Markdown scaffolds that I'm going to give you are going to evolve during the course. So in the first lab, you have a scaffold which has almost complete code. You will have to yourself do some interpretation of the data and read some libraries, but the scaffold is there. However, as this course is evolving, the scaffolds will become, will have less and less flesh on them. So you will be needing to do more and more. So the parts that we did in the first lab, I'm also already going to leave them a bit empty on the second markdown document, which is your scaffold, and so on, until the end, where you are going to have to do basically everything yourself, and also define a bit your goals and metrics and so on. So we start from a complete version and then we minimize it a bit step by step. The deadlines for the labs are going to be in before the next lab, so you have about more than 1 day to complete these labs. And I'm expecting you to submit the markdown file as well as an HTML code of the knitted R markdown. So in the lectures, we use both R as well as a bit of Excel. And this is more to play around with some things. And in the labs, we are only using R. So we do everything in the program, in our programming language. And finally, at the end of the course, we have the exam for the third part. And in the exam, we have a practical task. So you're given one task where you have to choose the method. You have to choose if it's a regression, classification, clustering, what is that task? You have to implement this, explain the outcomes, evaluate, suggest next steps, so say give a kind of a future perspective as well. And during the exam, you can use all sorts of materials that you have, but no communication among yourselves. The same is also actually true for the labs. So you can use all material, but you should not communicate between each other, or also ask help from some programmer or a chemometrician. So this is not what you should be doing. To help you, I also suggest a couple of resources. So you already are familiar probably with the Miller and Miller book, which is a very easy reading and a kind of an introduction to multivariate statistics. However, a more advanced book is an introduction to statistical learning, which is freely available. And this is also as PDF available in Athena on your course site. And to help you with R, to write good R codes, R for data science is also uploaded in your Athena. This book is written by 2 authors who also have developed Tidyverse, an essential package in writing R codes. So I really suggest you to have this. This is very easy book to just skim it through a bit and just read it a bit to write a better code and to make the best use of the modeling and data processing that you're doing, to make it easy, accessible for yourself and for others.